So E is defined as minus derivative of the voltage or potential with respect to X, if I'm talking about the X component of the electric field. So this means also that it's equivalent to say that the change in the voltage is minus the integral from initial to final, let's say from A to B, of E dot dx, Ex dot dx, the X component of the electric field. So a quick example on this one. Let's say the potential is given as, let's say, 3x squared minus 5. And the question is to find E at x equal 1, for example. Let's say that's in volts at x equal 1 meters, everything in a SI unit. So E becomes minus dV is the derivative of voltage with respect to x, so derivative of this V will be minus 6x, and when we substitute for x equal 1, so it's going to be minus 6 times 1, or minus 6, the unit is volts per meter. So negative, the magnitude of E is simply 6 volts per meter, and when I have minus means this electric field is going to be directed to the left if I'm taking the right direction to be the positive direction. So to make sure of that, this means here should be the high voltage, here should be the low voltage, and we can check for that. Let's say we find the voltage at x equal 1, and I'm gonna find the voltage, let's say, at x equal 3, and compare them. We'll see that voltage at 1 smaller than 3. So substitute, this is 1 squared minus 5. So 3 minus 5, it's minus 2 volts, while this one is 3 multiplied by 3 squared minus 5. So 9 by 3, 27. 27 minus 5, it's 22 volts. Clearly, the 22 is bigger than minus 2. So the electric field is to the left. And that's why we got here the minus sign. But anyway, we care for the magnitude. Another example, for instance, on this one, we want to find the change in voltage. Let's say Ex, E is along the x-axis, and it's given as, let's say it's uniform. So it's 2 volts per meter, positive. So it's directed along the x-axis. This means the change of voltage. Let's say I want to find, for example, V at 3 minus V at 2 at x equal 3 minus V at x equal 2. It's minus the integral from 2 to 3 of E dot dx. So this delta V is going to be minus 2x, and we substitute for x. First we substitute 3, then we substitute 2. You can do it using the calculator directly. So it's going to be minus 2 volts. So this is delta V. And again, it makes sense because the electric field is given to be positive, means the electric field is to the right. And as we know that, this means here I have the low voltage. Electric field goes from high to low. So here is the high voltage, and here is the low voltage. So this means delta V, which is V low minus V high, you should get negative. And that's why I got this negative sign here. Last example, the easy example, or the important case, if you have two parallel plates that are close to each other, and one of them is positive and the other is negative, we know that the electric field between them is going to be uniform. This is the electric field, it's uniform. So the spacing between the lines is going to be the same in order to show the electric field is uniform. And as you know, the equipotential lines will be simply lines that are perpendicular to electric field lines. So those are equipotential lines or voltage lines. And from the formula, which is delta V equal minus the integral of E dot dx, since E is uniform, you can take E outside, and delta x will be simply x, which is the distance between the two plates. This is x, I'm going to call it small d. So you will get minus E multiplied by d. So as a magnitude, delta V, the change of potential between two parallel plates, it's simply equal to E multiplied by d, the distance between the plus and the minus. For example, let's take an example here. If we have those two parallel plates, again a positive, again a negative, and I'm gonna take, let's say, any point. Let's take a point here, or let's consider the distance to be 1 centimeters, and the electric field between them is given as 2 times 10 power 3 volt per meter. I want to find the delta V. So delta V, it's ED. So it's 2 multiplied by 10 power 3 multiplied by distance 1 centimeter, which is 0.01 or 10 negative 2 of the meters. So you will get 20 volts. This is delta V. If you are considering delta V, V plus, V high minus V low, it's positive. If you consider delta V to be V low minus V high, it is minus 20. Thank you for watching.